Hello, we are the Intensity Podcast. We're going to take you through all about spectra and light. So,
Line spectra, Jack.
line spectra.
Oh, okay.
Crazy.
So, what does a line spectra tell us about the electronic structure of an atom?
Well, maybe we should start with how do we get line spectra?
Ah, that's just,
Yeah.
What do we get line spectra?
Oh, now you're cooking.
Good
question.
well, you use a prism. And you shine
Okay.
light.
Great, Jack.
You
That's,
look at
that's
it.
how we get light diffraction.
Very,
Not
very
spectra.
Light diffraction, yeah, but in that diffraction, there's a few pieces that are missing or are more intense than the other pieces, right?
We have
John holding court.
Yes, we're holding court.
Just making sure.
100%.
John's holding court. Let me see some little more dedication out of you, please.
Yeah, Jack, you got bad.
Yes, so lines,
This is going great.
yes, we just heard DK
DK
just
came in.
entered the
Our special guest, Dr.
That's
Keller.
guess number one.
yes,
Guess number one.
Dr. Kelleher. So, as I was saying,
Oh,
line spectra occurs when more intense peaks show up.
Peaks of what?
As transitions of electrons occur within atoms or ions.
typically the certain transitions between different transition states, like
Yeah.
how an electron goes from one to another, like from a singlet to a triplet.
Mhm.
And each color represents a different state.
Yeah, a different transition between states.
Yeah.
And
Such
So we-
as
those colors will represent those energy wavelengths, representing higher energy and lower energy based on the color. And the magnitude of the wavelengths being higher wavelength, less energy, less of a distance of the gap between the transition levels.
Yeah, that tells us how much energy between the difference of transitions, like the different energy levels of each species.
Kind of helps us discover more of this like quantized state, because we can actually quantify these numbers because we actually have like actual calculable variables going through each one of these states, instead of like more like a crap load of every single one is a certain state. We know a specific energy distance that will travel to, which will represent the state, instead of just every single individual line being every single individual energy level being a state.
well, I think that
How do these relate to lasers and dinosaurs?
Lasers and dinosaurs. How did we jump from line spectra to lasers and dinosaurs?
We didn't. I needed to do something with the blank space.
Oh, okay, I see.
Here, Nick, how about the meteor is the photon and all the dinosaurs are electrons. They jumped
Doesn't
up.
make sense because it wouldn't hit the electrons.
This is hypothetically.
Well, so if the
Yeah.
meteors are photon and all the dinosaurs are electrons, then we take this meteor, it's going to crash land into our subjective level, which is more or less the population of those electrons, and it will energize them to a state. And so we get flying dinosaurs.
do you think they'd get to?
And then we get line spectra. for
Flying.
each
Do
dinosaur.
they get wings? I think they get wings.
They're not
Once they
flying.
transition, they get wings, they turn into dragons, and then they find their level and then they calm down.
So how's that work again?
I don't
Okay,
think they
okay,
fly.
okay.
Well,
Jump.
then like that's your difference between an electron and then like a muon or something.
Wouldn't it be like the difference between the different sized atoms with different orbitals and then you're getting further away from the
You get different line
would have
spectrum.
different transitions.
Yeah, how high the dinosaurs fly will determine the color that's given off from them flying in the air.
Yeah, from their exploding impact, the energy being
Yeah.
given off would be producing this specific type of energy.
Yeah.
And the farther they go, farther they go is the higher energy, so they produce like a redder color
Yeah, they produce a redder color to your eye.
to our
Right,
perception.
To your
Yeah,
perception,
No, I don't think that's right.
but if. Not,
Wait, what are you saying?
if they go to higher energy, they will appear to be more red. Because
No.
opposite of what its actual energy is, which would be more of a blue color, which is higher.
we're
energy.
just basing it on the color spectrum, not going to all the other non-visible regions.
Yeah.
So
Being,
we're just talking about the visible region.
Kind of for right now, because it's more or less how we tell line spectra, because we can't really see the line spectra in the other regions, so we can only really deal in that region because that's where we actually see colors and we're able to determine the actual distances and determine potential wavelengths.
Okay. And then what can that tell us about the population of, species in each state?
Say dinosaurs.
No, I'm not going to talk about flying dinosaurs.
but that's so much more fun.
So much more.
I'm aware, but that's just confusing to me.
Well,
Wait, if each dinosaur is an electron, does that make Earth the atom?
Check how do you raise the volume?
Wait, repeat that?
Or would that make Earth the nucleus?
I guess so.
Yeah,
Are we saying that dinosaurs are jumping into space?
yeah.
Mhm.
Well, actually, they're being thrown into space. There's a difference.
Thrown into space. I see. I
From the
see.
meteor impact of the
I see.
photon exciting the electron
Oh, okay, that makes sense. That makes sense.
correlations.
This is great stuff, guys.
This is amazing. So
Only 6 minutes in, baby.
we did not answer the question of what does these transition tell us about the most populated versus least populated states?
Well, the
Um,
intensity would tell you about the population,
Yeah.
right?
How?
How? Well, that's a great question.
The
I thought
more
you were
intense the
dinosaurs.
light is, the more populated that state is. So that's most likely, I would assume, the first state. But
So you're saying the more intense it is, the more
yeah, because
common
the
that
red one
changes?
was the red one was the most intense one, right?
Yeah. So that was like the most
was-
common one. And
Yeah,
so
and that
that
was
would
the
be,
lowest energy one.
okay, so that would have the highest population.
That means it also has
Yeah.
to have the smallest energy difference between the states. That's again,
Okay.
Yeah.
Yeah, that makes sense.
Like, for example, if you have a transition from 2 to 1 state,
Hmm.
that's going to have more intensity than a transition from, let's say, 4 to 1. Because there's much less populated energy states there, even though there is an energy state 4 that's being filled with energy. When it relaxes back down and gives off light, it's gonna be less intense because it's less occupied.
Okay. That makes sense. All right, let's circle back to what Norman said about energy spacing. So is the energy spacing like constant in this series, or is it not constant between energy levels?
You're talking about increasingly, right?
Yeah.
Constant between energy levels.
Yeah.
Isn't it increasing?
Increasing?
Yeah.
as we get higher in energy, the differences will get smaller.
Oh, yeah, yeah.
Approach infinity to reach our energy of 0.
All the energies seem to get bunched up as you get higher up.
Oh, yeah, the spacing between them decreases
Yeah.
as it increases.
Yeah, as the overall energy increases.
It's still increasing just at a slower rate.
That's what was cool about, so I think it was the Lyman series.
Mhm.
Where. I believe it could have been the Balmer that, tells us how. It would tell us that we had some sort of limit, but the Lyman series would tell us that we could actually go even lower. We can go to an even lower transition energy um, to actually have a greater ionization energy for different transitions.
The Layman series?
And
Layman.
what region would that be in? Was that one X-ray?
Actually, yeah, we got it.
Layman?
And then it was passion that was above the visual. It's in UV.
Yeah.
What do those levels look like? Like the level spacing? Were those the same as the Balmer series, or were they more consistent? I don't remember.
I think they're very similar to the other electronic structures. Being that as you get higher, all of those higher energy states still compress very quickly.
Okay.
Guys, I finished my Chipotle.
You finished your Chipotle?
Yeah.
So now you
Great.
We need
invested?
an air horn.
You'll be fully invested?
Yeah. Yeah, how are we gonna make this back into dinosaurs?
Back into dinosaur, bet. Alright.
Oh God.
Dinosaurs can only fly so high, right?
Yeah, but we gotta explain why the ground state's even lower than lower.
Oh,
Yeah,
Like, this is
the-
0, we gotta explain why 1 is now down.
We gotta
to
talk
2,
about-
this is 2.
let's
We
see.
gotta talk about the little guys in the earth.
Lower gravity.
What?
Well, it makes kind of sense though, because if the photon hits the ground, there's a crater. Some of them are gonna fall in the crater,
Hmm.
They gotta go into the crater.
right? Yeah, some of them
And
go
then they
into
go
the
back up.
crater.
I mean, they'll kind of still be dead, the crater's kind of there, but like a giant rock's in the crater.
Yeah. But like, it makes an impact around it. Have you ever seen a crater from a meteor?
Yes.
Okay, well then you know that there's the space around it where shit kind of falls in.
Maybe this dinosaur thing isn't going.
Hey man, hey, you want big dragons or something?
How is dragons better?
They can
How is
fly, but
dragons
you can at least say that they can fly.
They can.
And exert X amount of energy.
Okay, we're acting like dinosaur. There's literally pterodactyls. Those are flying dinosaurs.
Yeah, but dragons got
Dinosaurs
fire.
can't fly.
And that is for the other series. Because they're already at a higher level. Oh, fuck.
Oh, the passion?
Yeah, or wait, hold on.
Yeah, passion's above, I'm pretty
Oh,
sure.
shine.
Oh, no. We
Wait,
had-
we could still end up putting together, because we
Flipping.
still have enough for another video or another Zoom.
Mhm.
So,
Yeah, we
Just
can
probably-
put them together. Okay, so this is gonna end in 10 minutes.
Cool.
Why don't I stop it now and then
Hey,
Get
wait,
Sean.
Jack,
Yeah.
just let it go
let it go?
and watch it upgrade to giving us more time to be unlimited.
Oh, no, it'll just end.
You sure?
It'll just end. It'll kick us out.
it's just gonna.
It's just gonna end.
I should
Uh,
have left Zoom then.
You have an upgraded one?
Nah, but mine always lets me go to unlimited for some stupid
have
reason.
you tried it recently? What was the
That's
last time
true.
you-
I haven't
Yeah.
tried it since last semester
I don't know
almost.
if it was, I'm pretty sure it's been like this since probably your sophomore year. Yeah.
Okay, fine. I'll just start a new Zoom. I'll invite you all again and then we'll get into it.
Alright.
Again, talk about
And we're
dinosaurs.
still on the topic of dinosaurs, all right?
This is a short intermission.
Short
Short intermission.
or commercial break.
Or one.
Brought to you by.
What is it?
Hey, brought to us by dinosaurs.
By
Dinosaur.
dinosaurs? No, brought to you by the Lewis Chemistry Department. Here's
Not
your-
dinosaurs.
Yeah.
I figure out what's the passion and all the rest of them.
Kind of, kind of a lot of times there's no difference between Balmer, Passion, and Lyman.